Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! So we're going to write an expression for the amount of people on the first bus. So they've started with X passengers and they've gone to 11 bus stops with X passengers. So altogether that is 12X. So we're going to have the first bus. And so we've got 12X. And then on the last bus stop, 19 passengers get on. So plus 19. Now for the second bus, well, we start with X and a further 5X come on. Because 5 bus stops with X passengers, so that's 6X altogether. And then 79 get on. And it says the first bus finishes with less passengers than the first. So the first bus finishes with less. And the way we show that is with this inequality here. Now all we need to do is solve that inequality. And we've got X on both sides, so we look at the X's. We've got 12X and 6X, so we always take away the smaller amount. So we're going to take away the 6X both sides. And next thing we're going to do is take away the 19 from both sides. And so, meant to be 60. Got ahead of myself. And the last thing we do is divide by 6 both sides. And so we've got X is less than 10. Now, it says here, assuming no passengers got off either bus, what is the largest value for X? Now, it is tempting to write down 10, but it says X has to be less than 10. So the biggest number we can get that is less than 10 is 9. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7. But I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. Try to get x on its own, and we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. The volume of any prism is found by working out the area of the cross-section and timesing it by the length. So we're given the cross-section here is 92, and the length is basically how 3D the prism is, so that's going to be times 4. So that's going to be 368, so 368 centimeters cubed. So we know that James knows that he has a square, so we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000. So that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. The important thing to realise in this question is that we know a female has been selected. So we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female's been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So and we're timesing them. So 10 times 10t, 10 times 10 is 100. So it'd be 100t. 10 times 4 is 40. So our answer will be 100t plus 40. The important thing when choosing a sample is that everyone has an equal chance of being picked. So if you look at method 1, picking the first 30 students who enter the school is going to have a bias because there might be a difference in the type of person who arrives early to school to the type of person who might arrive later. If we select a class in the school, then they're generally all going to be the same age. So if it's a year 7 class or a year 11 class, they're all going to be the same age. It might seem that it's fair that picking the first 30 students alphabetically, so A to F or whatever, again, that's not fair because the people at the end of the register don't have an equal chance of being picked. So you need to make sure everyone in your population has an equal chance of being picked. So picking 30 students out of a hat containing all the students' names in is definitely the fairest way of picking a sample from this list. So we're going to start by understanding that all lines form or can form an equation y equals mx plus c, with m being the gradient and c being the y-intercept. It says here the gradient is -2, so we've already got a bit of a head start with this, but we don't know what the y-intercept is. So we're going to use this first set of coordinates to work out what the y-intercept is. So y is -31 and x is 15. And we're going to use this to solve and find out what c is. So first thing I'm going to do is, well, just tidy this up. 2 times 15 is 30, so -30 plus c. And I'm just going to add 30 to both sides to get c on its own. So that would be -1 equals c. So c is -1. So we now know that the equation is y equals minus 2x minus 1. And we're told that the y is minus 37. And we're looking for the x value, which they've called w. So let's get our solving lines in. Okay, so the first thing I'm going to do is add 1 to both sides. And so it would be minus 36 equals minus 2x. I'm going to now times, or divide everything by minus 2. And a negative divided by a negative is positive. 36 divided by 2 is 18. And then obviously that gets rid of the coefficient of the x, so it's just x. So x equals 18. So the x value is 18 and the x value is the w value. So w is 18. So we're going to first of all work out where 9 is on the y-axis. Well, we've got 8 here and 10 here, so 9 will be halfway in between. And what we're going to do now is just draw a line across at 9, and then wait until it hits the line, and then we're going to draw a line down, and you can see here that x is 1. So our answer is that x equals 1. So I'm going to start just by writing out the equation, and I can put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says expand your answer fully. So we're just going to expand the brackets, 7m plus 70. So we're looking to write a formula for the cost in pounds of hiring a microwave for X amount of days. So the cost is C, so it's going to be C equals, and it says it's going to be 55 pence a day. Now, it wants the answer in pounds, so we need to convert this 55 pence into pounds. So that's going to be 0.55. And it's going to be 0.55 times the amount of days. Well, it says the amount of days is X. So it's going to be 0.55x. Then it says that there's just a one-off cost of £15. So you're going to have to pay £15 regardless. So we're just going to add 15 onto that. So the answer would be C equals 0.55x plus 15. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it, so I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power of 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. So it'll be x to the power of 16. And then y to the power of 4 times y to the power of 4, we just add them together, so it's y to the power of 8. First thing we need to do is work out the volume of this prism, and it's a trapezium-based prism. So the volume will be the area of the cross-section, or area of the trapezium, times the length, how 3D the prism is. So trapezium is half a plus b h, and then times the length. Now A and B are the two parallel sides, which will be this one and this one. And then the h is the perpendicular line that hits both of them at 90 degrees, which is what perpendicular means, between the bases. So this will be the 25 meters here. So it's going to be half, and then we're going to add 1 and 5, times that by 25. The length is how 3D it is, so it would be that 10 there. So we're going to times that by 10, and that will give us 750. So it's 750 meters cubed. Now, there is a little formula we can make for the rate. So the rate of anything, for this, will be the volume gained over time. Now, with this question though, we're interested in the time it will take. It says how long will it take. So we're actually looking at the time. So it will be time equals the volume, which is 750, over the rate, which is 15. So 750 divided by 15 is 50. So it will take 50, and let's have a look. It says per minute. So it would be 50 minutes. We know that all linear graphs follow y equals mx plus c, with the m being the gradient and the c being the y-intercept. So looking at this graph here, the c is the number and sign at the end, which is -5. So it's going to hit the y-intercept, or it's going to hit the y-axis at -5, which will be here. And the gradient is the number before the x. Well, it doesn't look like there is a number before the x, but that's because it's a 1, and we don't show a 1. So the gradient is 1. It means for every 1 we go to the right, it's going to go up 1. So it's going to go up 1, and then up another 1 for every 1 it goes to the right. So it's going to be at -4 here, and then it's going to be at -3 here. And let's draw in that graph and make sure that the graph goes for the full, or the line goes for the full graph. So it's going to go somewhere like this. We can write the equation of all straight lines as y equals mx plus c, with m being the gradient and c being the y-intercept. Now the y-intercept is the nice easy one to find because it's just where the line hits the y-axis, which is at -1, so c is going to be -1. Gradient's slightly harder. What we have to do for the gradient is find two coordinates that we know. Well, I'm going to use the same coordinates I've just found out from the y-intercept, and preferably we want them next to each other, so this one here is a nice one. And the gradient is basically for every 1 we go to the right, how far up we go. And we can see here that we've gone 3 up. So the gradient therefore is 3. And so writing that all out in the equation, it's going to be 3x minus 1. It's sometimes easier in these questions to view these triangles as two separate triangles rather than one triangle. So we're kind of just going to split this triangle off and just move it to the side so we can see what's going on. I'm going to do the same with the smaller triangle and kind of move that to the side. So we can see we've got two triangles here. We've got a big triangle and small triangle. And we can label the sides of them as 18. Now this long length would be 20 plus x, 20 centimeters plus x. Then we've got 6 here and we've got x here. Now the two triangles are similar because the sides here we assume are well, we know they are parallel because they are right angles, and they share an angle here, which we can just label as A, and so they are definitely similar, which means that one is an enlargement of the other. So we need the scale factor first. Now if you look at the 6 and the 18, they are what we call corresponding sides. So we need to work out the scale factor by finding out what I multiply the 6 by to get to the 18. Well, that's obviously going to be 3. So we now know that we can times the x by 3 to get to the 20 plus x. So we can write that down. 3x, I'm timesing the x by 3, and that will give me 20 plus x. And so I can solve this now. subtract x both sides, always subtract the smaller amount, so 2x equals 20, and then divide both sides by 2. And so we've got x equals 10. So we know that x equals 10, it says find the length x, and so that will be 10. So we're going to first of all draw a tree diagram for this information. You don't have to, but it is easier to understand what's going on. And so the first choice will be the first pick. It'll either be male or female. And the second choice will be the same, male and female. And looking at the questions, there are 3 male names in the hat and 5 names in total. So the fractions for the first one will be 3 over 5. If there's 3 male names, there'll be 2 females. Now, if we've picked a male name already, there'll be 2 left and 4 left in total. If we haven't picked a female, there's still 2 females, but there's 4 left in total. If we picked a female, there'd still be 3 males and only 4 left in total, but there'd only be 1 female left. 1 female name left and 4 left in total. Okay, we're looking for the probability that the genders of the names are different. So looking at the outcomes, the outcome here would be male-male. That's not what we're interested in. Here would be male-female, we are interested in. Female-male, we are interested in. And female-female, we're not interested in. So we're not interested in these ones. And the way that tree diagrams work is as you go along the tree, any fractions you go across, you multiply together to find the outcome. So this will be 3 over 5 times 2 over 4. And I realise I could cancel 2 over 4, but I generally cancel at the end. So 3 times 2 is 6, 5 times 4 is 20. We're going to do the same with the other root. So 2 over 5 times 3 over 4. So 2 over 5 times 3 over 4, 3/4. That would be 6 over 20. Now we're looking to see whether it was male and female or female and male. And the word or in probability means add. So it'd be 6 over 20 plus 6 over 20. And this is the probability of different. Which will be 12 over 20. Now 12 over 20 will cancel to 3 over 5, or 3/5. So we can't work out length CE directly, but what I'm going to do is I'm going to start off by finding length BC. And I'm going to do that using trigonometry. So we've got the 90 degrees there. So it will be, well, we'll start by labelling it. So BC is the hypotenuse, the opposite here and adjacent here. We're not using the adjacent. So we're going to just do our SOHCAHTOA, and we've crossed out the A, so we cross out these two. So it's going to be sine. So we know that sine 79 equals the opposite, which is 29 over the BC. So I'm going to put my solving lines in. And we need to times both sides by BC first of all. So we end up with BC sine 79 equals 29. And we're just going to divide both sides by sine 79. Just a bit of rearranging. So BC will be 29 over sine 79. And when you do that on the calculator, you get 29.542, blah, blah, blah. Okay, so next thing we need to figure out is angle BCE. So where are we? This angle here. And to work that out, we're just going to take 79 away from 90. So angle BCE is 90, take away 79, and that's going to be 11. So we know this is 11 degrees here. And we have enough information now to work out CE, because we've got this triangle here, and we've got this length here, the BC, and we've got this angle here. So we've got enough information now. So we're going to look for length CE. We're going to first of all label the sides. So we've got the opposite here, the hypotenuse opposite the right angle here, and the adjacent here. So this hypotenuse is now an adjacent. We're not using the opposite at all, but we are looking for the hypotenuse. So let's do our little triangles now, find out which one we're using. So we're not using O, so we get rid of sine and tan, and it's going to be a cos. So it's going to be cos 11 equals the adjacent, which is the BC value we've just worked out, over the hypotenuse, which is CE. Now hopefully you've realised from when we did it with the sine thing here, that actually we can just swap these two things over. So we can have it as CE equals 29.542 blah 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 over cos 11. Okay, then we put that into our calculator and we get the answer of 30.095 blah blah blah, and it wants it to one decimal place, so that will be 30.1. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves, so we'll have green on the left and brown on the right, so green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the center X, and we can say that there are 19 take away X just green, because they could have been both green and brown. And for the brown we can do the same, so it'd be 15 minus X. And for the next step, we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus X, the 15 minus X, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus X and minus X, that's be a minus X. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by minus 1 both sides to make them both positive. So now we know X is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8, and 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. To find the area of a rectangle, all we do is the length times the width. So the length, doesn't matter which way around we do this, is say 2.4, and the width is 9.8. But it says it wants to find the minimum area. So to find the minimum area, what we want to do is find the minimum length and the minimum width. So it says it's rounded to the nearest tenth of a centimetre. So we can do some quick lines, some quick number lines here to find what the minimum would be for both of these. So for 2.4, the next number down would be 2.3, and we just find the halfway point. Halfway point would be 2.35. And similarly, with 9.8. Next one down would be 9.7. Halfway point would be 9.75. So we're going to find the length, which is 2.35, times it by the width, which is 9.75. Let's just do that a bit nicer. And that gives us the answer of 22.9125. So it'd be 22.9125 centimeters squared. So we can see with this simultaneous equation, we've got the coefficients of the x being different and the coefficients of the y being different. So we're going to focus on making sure that the coefficients of the y, the 3 and the 5, are the same. So we've got to figure out the lowest common multiple of 3 and 5, which is going to be 15. And so I've got to make them both 15. So we're going to start by writing out the first equation. And there's nothing to stop you getting the x's the same. I just always focus on the y's. And we're going to times everything by 5 to get that y to be 15. So 5 times 5 is 25x plus 15y. And then we're going to do 8.5 times 5, which is 42.5. And we're going to do the same with the second equation. Just going to write it out. And then we're going to make that second term 15y. And we're going to do that by times everything by 3. So 6x times 3 is 18x plus 15y, and then that's going to be 18. So we're going to write these equations again, so we can work our simultaneous equation magic on them. Okay, so first thing I'm going to do is just do my circles going downwards, because simultaneous equations are all about going downwards. And I'm going to look at the signs of the y's because we made them both the same. So looking at the signs though, if the signs are the same, we're going to subtract. If the signs are different, we're going to add. So the S is same, S in subtract, D in different, D in add. Now you can see that they're both pluses. So they're the same, so therefore we're going to subtract. And we're not just going to subtract those, we're going to subtract all the numbers going downwards. So we're going to start off with 25x take away 18x, which is 7x. 15y take away 15y is nothing, which is good. We need that to be 0. And then 42.5 take away 18, which is 24.5. Get our solving lines in. We're going to divide both sides by 7 to get x on its own. So we've got x equals 24.5 divided by 7, which is 3.5. Okay, but that's only half the battle. We've got to work out what y is. So what we're going to do is we're going to substitute that into the first equation. So we've got 5 times 3.5, because we know what x is, plus 3y equals 8.5. And so 5 times 3.5 is 17.5, so we're going to subtract 17.5 from both sides. And that's going to give us minus 9. And then we've got 3y, so we want to divide by 3 both sides, which would be minus 3. We can check that by substituting it into the second equation. So 6 times 3.5 plus 5 times minus 3, and that does equal 6. A box plot starts with the lowest value. Then it goes to the lower quartile. So we have the lowest value, then the lower quartile, and then we have the medium, then the upper quartile, and then the highest value. So lowest value is at 1 on this one, and normally we just put a little kind of line at the end here. So we're going to put a line at 1, and I'm just going to put that line there. Ooh. A little bit further to the right. There we go. And our lower quartile is 9, which is kind of where the box starts. So we're just going to start a box there. We're just going to connect these up. There we go. And our median is 11, so we're just going to show that. Quite a thin box plot so far. Now it says the interquartile range is 5. Now the interquartile range is the distance here, so that's 5. So it's going to be 5 more than the lower quartile. If the lower quartile is at 9, it would be 9 plus 5, which will be 14. So if we get our line at 14, and then complete our box plot. Here we go. Now the range is the total distance of, or the total width of our box plot. So that's 17. So that's going to be 17 higher than the lowest value. Now the lowest value is 1, so 1 plus 17 is going to be 18. So I'm just going to, there we are. And we're going to have that at 18. And again, I'm just going to put a line there. So we're going to first of all find out how many potatoes were below 22 grams. So we're going to draw a line up at 22 and a line across, and that is 13. So there are 13 potatoes below 22 grams. And so to work out the probability of picking one below 22 grams, it's the amount that we have below that amount, or below that weight, over the total amount of potatoes, which will be 20. So it'd be 13 over 20. Which is equal to 65 over 100, so that would be 65%. We're asked to solve this quadratic, and we're told we're going to leave it to 2 decimal places, so chances are it's going to need the quadratic formula. And for the quadratic formula, we need to find out what a, b, and c is, or are. A is the number for the x squared. Now, it doesn't look like there is a number there, but actually there's a 1 there, so a is 1. B is the number before the x, that's going to be 12, and c is the number left on its own, which is going to be the 5. I'm going to write out the quadratic formula, but we're going to put in the values that we've just found, the a, b, and c. So the quadratic formula is minus b, and I'm going to put it into brackets, and all the substituted values I'm going to put in brackets, plus minus square root of b squared, again put it into brackets, minus 4 times a times c. And you might ask, why am I putting them all into brackets? If they're negative, you can get yourself into real problems if you don't put them into brackets. So just put them all into brackets, you'll never make the mistake. And we've got x equals, so we're going to put this into our calculator with a plus there, and if we do that, we get x equals minus 0.432 blah blah blah. Use your calculator to go back and change that for a minus, and you get the value of minus 11.567 blah blah blah. Well, asked for 2 decimal places, so that's going to be minus 0.43 and minus 11.57. Going to start off by labelling the triangle, and so we've got capital A here, capital B, capital C, and lowercase a, lowercase b, and lowercase c. It doesn't actually matter which way around b and c are, but capital A is always the angle that we're given. So we've got to work out whether we're using cosine rule, sine rule, or something else. Well, here we're given 3 lengths. Well, actually one of them is unknown, but there's 3 lengths involved and an angle, so that's definitely going to be cosine rule. So we're going to write out the cosine rule for when we've got a length, which is the one that starts with a squared. So it's a squared equals b squared plus c squared minus 2bc cos a. And let's fill in the numbers we've got. So that's going to be 3 squared plus 5 squared minus 2 times 3 times 5 times the cosine of 22. And when you type that into the calculator, you get 6.184 blah blah blah. But that's what a squared is, so what we need to do now is just quickly solve that by square rooting both sides. And so we get a equals 2.486 blah blah blah. It says it wants its 2 decimal places, so that's going to be 2.49. When solving simultaneous equations graphically, the solutions are just where the 2 graphs meet. So we've got y equals x plus 4 drawn, and we've got y equals x squared minus 2 drawn. So the solutions will be here and here. So the coordinates will be x equals -2 when y equals 2 and x equals 3 when y equals 7. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got 2 radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagram as 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realizing is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got 3 of the sides, we can work out the last one. So angle DOB is going to be 360, take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360 take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360 take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference, and the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should really put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead, and we've got 3 of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know, so the 228, the 13, and the 66. And the reason being the same as before, so angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. We're going to start by working out what outcomes will give us 2 different types of drink. So we could have OA or AO. We could have AW or WA. And we could have OW or WO. Now what we notice really when we do this is that OA gives us the same probability as AO. Same with AW and WA, same with OW and WO. So we're going to just ignore the right hand side ones, and we're just going to focus on the left hand side ones. To work out the probability of O and then A, so orange juice then apple juice, we work out the fact that it's 6 over, well, the probability of picking orange juice first of all is 6 over 27. And then if we picked an orange juice, the probability of picking an apple juice would be 9 over 26. And so that would be 54 over 702. Apple juice then water would be 9 over 27, and then 12 over 26, and so that would be 108 over 702. And then orange juice then water will be 6 over 27 and 12 over 26, and that would be 72 over 702. Now we're looking at the probability of this or this or this, and the word or means add. So the probability of OA or, I should put that in brackets, probability of OA or AW or OW is these added together. And when you add them together, you get 234 over 702. Now, I said we would deal with the reverse situations now. I'm going to deal with that now. And as I said, OA is going to be equal to AO, AW is equal to WA, and OW is equal to WO. So all we need to do to find the probability that the drinks are different is get the 234 over 702 and just double it. And we can do that by just doubling the numerator. So 468 over 702. That cancels down to 2/3. So there is a 2/3 chance that the drinks will be different. So we're told that y is inversely proportional to the cube root of x. And to get rid of this proportionality sign here, we just convert it to an equals and times the right hand side by k, which represents a constant. And we now need to figure out what that constant is. So we're going to feed in the value of y and x that's given to us in the question. So we've got 10 equals k over the cube root of 343. Okay, next thing we're going to do is we're going to solve that. So put our lines in. Now the cube root of 343 is 7. So we can actually just, it's a lot easier, and we're just going to times both sides by 7. So k equals 70, and we're just going to rewrite this, but instead of k, we're just going to write 70. So y equals 70 over the cube root of x. So we're going to start by completing the square, which it's asked us to do. And so to complete the square, what we do is we put a set of brackets down, and we put x minus half of the coefficient of the x, so minus 5, and square it. And if you were to expand that, you get x squared, brilliant, minus 10x, fantastic, plus 25. So we need to remove that 25. And then we've got the minus 11 there, just that was on the end there. When you tidy that up, you get minus 36. Okay, now I'm going to draw the graph of y equals x squared. Oh, I'm going to sketch it. It will look something like that. Probably a bit of a curvier bottom on that. Let's try again. So it's going to curve at the bottom and go up like that. Okay, and the bottom of it, this part here, is at the coordinate 0, 0. Okay. Now, we remember, hopefully, from graphic transformations, is if you have got a minus 5 on the inside of a function, And if we imagine that this is our f of x, then this would be our f of brackets x minus 5, because it's got the minus 5 there. We move the graph to the right 5. Remember, it goes the opposite way. So if it's a minus 5, it goes to the right. If it's a plus 5, it would go to the left. We also know that if you have a minus 36 on the outside, which we do here, it moves it down 36. So it's going to go down 36. So our new minimum point won't be at 0, 0. It will move to the right 5. So the x coordinate will be 5. And it will be moved down 36. So it will be minus 36. When asked to simplify an algebraic fraction, you will almost always need to factorise either the numerator, the denominator, or both. On this question, we need to factorise both. So I'm going to start off by factorising the top. Now you'll notice that this is a difference of 2 squared, so this is nice and easy to factorise because it will be x plus 2 and x minus 2. And we've got loads of videos on how to identify and deal with difference of 2 squareds if you don't know how to do that. Similarly, the bottom is just a simple quadratic, so we're just going to factorise that. Again, we've got videos on how to factorise quadratics, so have a look at those if you need to. Then we're going to look at top and bottom and see if there's a bracket that's the same, which there is, this x minus 2. So we're going to divide top and bottom by x minus 2. And that will effectively get rid of the x minus 2 at the top and the x minus 2 at the bottom. It won't get rid of it, it will just turn it to 1, and then it will be x plus 2 times 1 and 2x minus 3 times 1, which will just be x plus 2 as the numerator and 2x minus 3 as the denominator. As always with this type of question, we want to get rid of the fractions or brackets if we have any. Here we've got some fractions, so we're going to start by getting rid of them. I'm going to start by copying down the question, and I'm going to give plenty of space because these kind of questions do get out of control quite quickly. And so we've got 2 over x plus 10 over x plus 10, and then we've got equals 7. So I'm just going to scroll down and just give us lots and lots of space. Put my tram lines in for the equals. Okay, first thing I'm going to do is I'm going to get rid of the fraction on the left hand side. I'm going to do that by timesing everything by x. And don't forget, it's not just both sides, you've got to times all the terms. So we're going to times the first fraction by x, which will just give us 2. Times the second fraction by x. Well, when you times a fraction by something, you times the numerator. So it would be 10x over, and it would be x plus 10. Denominator stays the same. And here it just becomes 7x. Next, we're going to get rid of the second fraction's denominator. So we're going to times by brackets x plus 10, both sides. Okay, so 2 times x plus 10 is just going to be 2 brackets x plus 10, but I can actually just expand it now. 2x plus 20. Then it's going to be 10x, because the times x plus 10 just gets rid of the denominator. And then here, let's try and expand this as we go. And so we do 7x times x, which is 7x squared, and 7x times 10, which is just 70x. Next step we're going to do is just move everything on the same side. Now, I normally keep the x squareds positive if I can. So wherever the x squared is, I move everything else to that side. So we're going to collect the 2x and the 10x, and we're going to take away 12x from both sides. So we've still got that 20 on the left hand side, and here we have 7x squared, where is it going to be, plus 58x. I'm going to take away that 20 from both sides, because with quadratics, to solve them, we always need it to equal 0. Right, now, little hint in the question, it says, write your answer to 2 decimal places. That normally means we're going to be using the quadratic formula, and looking at this question, it doesn't look like we can factorise it. So, quadratic formula, we need to know what a, b and c is, or are. A is the coefficient of the x squared, which is 7. B is the coefficient of the x, which is 58. And c is the number on its own, which is minus 20. The quadratic formula is x equals minus b plus minus the square root of b squared minus 4ac, and all of that over 2a. So, putting in the numbers, it would be minus brackets 58, and I always put brackets around these, because if they are negative, it makes it a lot easier and a lot more reliable. Minus 4 times the 7 times the minus 20. And all of that is going to be above 2 times the 7. Okay, so we type that into our calculator with a plus, first of all. So you get your calculator out, type all that out, and you should get 0.331, etc. And then on your calculator, you go back to that plus and change it to a minus, and you should get minus 8.62. Oh, hang on, that's not quite right. 8.617, blah, blah, blah. Rounded too early there. And then when you round those, you should get 0.33 to 2 decimal places, and the other one will be minus 8.62 to 2 decimal places. And looking at that, so a tan graph, a normal tan graph, starts at 0, 0, and goes up to, I'm going to call it positive infinity. It's not quite right, but you get my point. It goes up very, very high there at 90, and then starts down here just after 90, and then goes to 0 at 180. But here, we're told that we're going to add 1 to it. So each of the points we're going to add 1. Now, it actually might help us to know that there is another point here. Tan 45 is 1, so actually that might help us here. And so tan 135 is actually minus 1. So this will give us a little bit of a hint about how to go about doing this. So all we're just going to do is move all the coordinates up by 1. And then we try and draw that out. Now, this first bit's going to be fine, because it's just a curve going upwards. This is going to be slightly more difficult, because we're kind of guessing somewhere around there. And it's going to go back to 180 there. Okay, so we're going to start by creating a cuboid, just so we can kind of visualize what's going on a little bit easier. And so the lengths on the cuboid, it says, are 14, 10, and 8. Doesn't matter which way around. Now the longest part of the cuboid will be the diagonal across it. So if I just show a diagonal there, and it doesn't really matter which one we pick. Ooh. I could pick this one here, go diagonal like that. They're all the same length, all the diagonals across. So the rod will be, if it's the maximum length of the rod, it will be along this diagonal. So we can first of all have to work out what this length here will be, and then we can use the fact that this is 8 here and work out what the length of the diagonal is. So I'm going to call this x, and I'm going to call the diagonal y, just so we've got something to refer to in our working out. And it might be helpful that this side here is 10. So we've got a right angle triangle, because this is right angled here, and we're looking for the value of x. So we know that we're going to be using Pythagoras, because we've got 2 lengths and we're looking for a third length. So it's a squared plus b squared equals c squared. So it would be 10 squared plus 14 squared equals c squared, and it's actually not c, we've called it x, so why don't I stay consistent, equals x squared. So I'm going to do 100 plus 196, which would be 296, equals x squared. And get our lines in. Should be quite easy because we just need to square root both sides. So I'm just going to square root that, and we get an answer of 17.20 blah blah blah. Now I'm going to keep that value in the calculator itself because I'm going to use that to find out what y is, our diagonal. So the next thing we're going to do is, we know what this is, and this creates a right angle triangle here, and so we're just going to do exactly the same thing again. A squared plus b squared equals c squared. Our a is 8, so 8 squared plus, and then we've got 17.20 blah 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 squared equals, and then we're looking for y, so y squared. Now if I square the value that's in my calculator from before, the 17.20, and if I just click square it, it will put it back to 296 because I've square rooted it and then I'm just squaring it again, so it would be 64 plus 296 equals y squared. So I'm just going to add them together, which will be 360. And again, I'm just going to put my solving lines in. Not too difficult to solve this. Make them a bit nicer, because I'm just going to square root both sides. So I'm going to square root this, and it gives me the answer of 18.9736 blah 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 equals y. Now it says it wants the answer to 2 decimal places, so it would be 18.97 to 2 decimal places. Now a different way we could have done this is we could have worked out y straight away by working out the, like, I don't know what to call them. I'm gonna label them A, B, and C. So A, B, and C. And what you can do is you can do the y squared equals a squared plus b squared plus c squared. It's basically the width squared plus the length squared plus the height squared. And so we would have had 14 squared plus 10 squared plus 8 squared. And when you've done that, you would have got 360. And this would be y squared equals. And then when I put the solving lines in, I would have done the same thing, square rooted both sides, and you obviously would get the 18.973 blah 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 again, and then you would have written down the answer. So there's two different ways of doing that. Obviously this way is a lot quicker, but you have to just remember that if you've got 3 lengths on the cuboid and you'll ask for the diagonal, then this formula here can be a much quicker way of finding the answer. We're going to first of all work out the frequencies for each of the bars. So we're just going to do the class width times frequency density. So for this first one, it's going to be, 1.2 times 10, which will be 12. 3.2 times 20 for the next one, that will give us 64. And the last one will be 16, so 20 times 0.8. Okay, add them up, check it equals 92, which it does. Now to find the position of the median, we're going to do n plus 1 over 2. N is 92, so it's going to be 92 plus 1 over 2. And so that's going to be 93 divided by 2, which will be 46.5. So the median will be in the 46.5th position. Okay, so where is 46.5? Well, the first 12 are in the first bar here. The next 64 are in the next bar here. Now 46.5 would be in that group. And whereabouts is it going to be in that group? Well, what we're going to do is we're going to take away the 12, because they're in the first group, and it is 34.5th in that group. So if there's 64 in total, it will be about here. Okay, so the frequency will be 34.5, so there will be 34.5 of them in that group. So what fraction in that group is it? Well, the fraction will be 34.5 over the total frequency in the group, which is 64. And so you work that out on the calculator, so divide that by 64, and you get 0.539 blah 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 blah. Okay, now we've got to work out, we're not really interested in the frequencies, we're interested in what this distance here is. And so the total distance in the group is 20, the class width of the group. And so we want to find out what the 0.539 blah 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 times the total class width is. So we're going to times that by 20, and we get the answer of 10.78125. So this is going to be 10.78125 down here. But we need to add it on to the 10 that we have already. So we've already got 10 there. So we're just going to add the 10 and the 10.78125 together, and that will obviously give us 20.78125. And once it's two decimal places, so it's just going to be 20.78. So we're finding the area underneath this graph, and that's how we're going to estimate the distance, because the distance is the velocity times the time. And so if we work out the area under the graph, then we've got the distance. But the issue is that we don't understand things like calculus yet, and we've got to use this thing called the trapezium rule. Now for the trapezium rule, what we do is we draw these lines up and we draw little trapeziums, like so, all the way up it, and in regular intervals. So here we can see the interval is every 2 seconds, and we draw these little trapeziums. Now it's often helpful to actually label them, so I'm going to label them A, B, C and D. And the formula for a trapezium, or for the area of a trapezium, is half brackets A plus B close brackets times H. Now A and B are the parallel sides, and H is the perpendicular distance between them. So let's do this for the area of A. So it's going to be half brackets. Now A and B are the parallel sides, so it's going to be this side here and this side here. So that would be 2 plus 1. H is the perpendicular distance between them, so this bit here. So it's on its side, so the height is actually the width, isn't it? So we're going to times that by 2, and that gives us 3. Okay, and you notice here that the half and the times 2 actually cancel each other out, so all we need to do is just add the A and B's together. So to find out what B is, we're just going to add the 1 and the 2, and B will equal 3. To find out what C is, it's 2 plus 5, which is 7, and to find out the area of D, it's going to be 5 plus 10, which is 15. So that's a bit of a quicker way of doing it than having to type it into the calculator each time. Then to find the total area, it's just going to be all of those added together, which will be 28. Now notice, this is useful for some questions, notice that actually there's a bit of a gap here, and I'm just going to shade it in green. It's a bit of a gap between our trapezium and the actual distance under the curve. So here the trapezium is actually adding on a little bit more area than we want it to. And what you'll find is a curve that looks like this, the trapeziums will actually add too much, so the area will be too big, and for curves like that, the trapeziums will actually not give enough area, So sometimes there's questions on whether it's an overestimate or an underestimate, and that's how you can tell. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.